Hello everyone, I hope you're doing well. So in this video, we're going to discuss some of the solutions from Google Kickstart round G, and we're going to discuss the first two problems completely and the third problem partially. So let us quickly start with the first question. So this particular question says that there is a particular competition which lasts for n days and there are m number of participants. Right. So like we have a character like John, and we have to tell by how many steps is he far behind the maximum number of steps for that particular ith day. So for all m participants, we will have a certain number of steps for all of those n days, right? So let me just directly show you the example. In this case, there are 3 days and 2 participants, right? So we have been given some values. So for all across all these 3 days, we have to tell whether participant 1, by how many steps participant 1 is behind the maximum number of steps for that ith day, right? So just let us quickly read this example. In this particular case, we are talking about participant number 1. Now the participant number 1 on the first day has 1000 steps, and the maximum number of steps by any participants on that particular day is 1500. So our character John is lagging behind by 500 steps. So we add 500 to the answer. Now similarly, on the second day, he has covered 2000 steps, and all another character has covered 1500 steps. So basically what we have to do is we just have to add 0 to it, because 2000 is already greater than 1500. Similarly for 3000, 3000, they're already equal, so we don't need to do anything. Similarly, in all other cases, let us consider this particular case. Now we have to consider character number 3. So this particular character on the first day has 500 steps, and the maximum on that day is 1500, this particular value, right? So we have to add 1000 to our answer, right? And in this particular case, he has 4000 steps, which is already the maximum on the second day. So we add nothing to the answer, and hence our total answer would be 1000. So we just have to compute the difference for the ith day. We just have to find the value of the maximum number of steps on that particular day minus the steps taken by our character John, right? So this is exactly what I have done in the code. This is the code for the first question, where I take all the inputs m, n, and x, and I create a double dimensional vector of size n cross m. So I take the input and I initialize my answer with 0, and I decrement the value of x for 0 based indexing, right? So what I do is I run a loop from 0 to less than n for all of those days, right? And for each of the day, I find the maximum element in that particular day. So the maximum element would be the maximum number of steps taken by any of those participants on that particular day. So where I find this value, I just subtract v of I comma x from it. So it will be the number of steps taken by our participant x, which is John in this case, and on the ith day, right? So we just have to add this particular value to the answer, and we can just finally print our answer for the first question. So this was the solution for the first question. Now moving on to the second question, which is curling. So this particular question says that, so this was just some extra statement. The main question lies around here. So it says that there are some stones which are a disc of radius rs, and the house is a bigger circle which is of radius rh, right? And the bigger circle also called house is centered at 0, 0. Now only the stones which are inside the house are considered storing. So a stone is considered if any portion of the stone lies within the circle representing the house. So basically there will be some bigger circle known as the house in this particular question, and it will be centered at 0, 0, and its radius would be given as RH. So this is RH, and we are given some discs, and its radius is RS, right? So a disk is considered inside it if it is completely inside it, if it is partially inside it, or even if it is just touching the bigger circle, right? So this is also considered inside. So how do we find whether the disk is inside or not? So we can just basically so this is the maximum case where the disk can be inside, right? Now in this case, the total distance of the disk from the center of the disk to the center of the house would be equal to rs plus rh, right? So this is the maximum permissible distance. So if the disk is at any distance greater than this particular distance, right? So if the distance is greater than this particular distance, then the answer would be no, that the disk is not inside the house, right? So this is the first part of the question. Now the second part says that each team is awarded 1 point for each of their stones such that no opponent stones in closer to the center than it, right? And no two stones are at equal distance from the center, right? So if we have been, so if there will be two teams, red and yellow. So if team red has a stone here and team yellow has a stone here, assuming that this particular stone is closer to the center than this particular stone. So team yellow will get a point for this particular stone, but team red will get no point because there already exists a stone Y from team yellow which is closer to the center than this particular stone. So this is how we compute our answer. Now let me just show you an example, right, like this. So this particular red disk is closer to the center and from this particular yellow disk. So the red team gets 1 point for it. Now considering the yellow team will get 0 points because there is already a red disk closer to the center than it. And similarly for this particular disk, team red will also get 0 points because there already exists a yellow disk which is closer to the center than the red disk, right? So in this case the answer will be 1 comma 0. We just have to calculate the points for both the teams. Team red will get 1 point and team yellow will get 0 points. So this is also a very direct question. Let us have a look at the code directly, what it says. So here I have taken two radiuses of of the disk and of the house as input, and I calculate some values in vectors h and y. So I'll be storing the distance of red disks in S, distance of red disks is from center in X, and similarly distance of yellow disks from center in Y. So this is the information that will be stored in these two vectors. Now I just take an input n and I just run through a loop. So like this will be for all red disks. Now I just take their coordinates and I compute the Euclidean distance from the center. So it would be a square plus b square and the root of it. So I'm taking the root and just pushing back into the vector x, right? Now similarly I just take m values and push it back in the vector y. Now I'm just sorting all the values so they are arranged according to their distance from the center. Now I take two variables px and py which represents the points of the first team and the points of the second team. Now I just check from 0 to n if distance xi minus d is less than or equal to h. So what I'm calculating this particular expression. So I'm just checking whether that particular disk is actually present inside the circle or not, inside the bigger circle which is also known as house or not. So x of I would be the distance of that particular disk, minus d is I'm subtracting the radius because I've already told that the maximum permissible distance is radius of house plus radius of disk. So I could have also written it as h plus d. So this is also correct, but so this is also correct that the distance of the disk should be less than or equal to the maximum permissible distance, right? So you can write it in any of the ways, and I'm also taking the condition that m should be less than 1. So what does m should be less than 1 means? Either there are no disks thrown by the opponent, so m is the number of yellow disks, so either there are no yellow disks, or the distance of the current red disk is less than the distance of the first yellow disk. So first yellow disk means the disk that is closer to the center. So if this distance is smaller than the distance of the closest yellow disk, then we will increment 1 to the score of the first team. So either there should be no yellow disks or the distance of the current red disk should be less than the distance of the closest yellow disks to the center, right? Similarly, we do the same things for all the yellow disks. We just check whether or not if it is present inside the disk, and we check either it should be there are no red disks or the distance of the closest red disk to the center should be greater than the distance of the current yellow disk. So in this case we increment the points for the second team, and at the end we just print px and py, which are the points for both the teams respectively, right? So this would be the solution for the second question. Now moving on to the third question. So I'll be just telling the solution to the partial part of this particular question for test set 1, and let us discuss it. So this particular question says that we have been so they define B, L and R as the sum of subarray. So if we are considering F, B, L, R, so it will be the sum of subarray B from the range L to R, right? So we just have to calculate this. Now an array of length K is called happy array if the prefix sums R of C is non-negative, right? So let me just show you an example. Let us consider this particular case. The question says that if we have this, then if we calculate the prefix sums starting from the first position, then there it is 1 and then it is -1. So this particular array, this is only the happy array starting from this index, because from the next index the value of the prefix sum could be -1, right? And again, if we start from the second position, so it is already -2, so I cannot take this from this particular position, right? If I start from the third position, then it will be 3, -2 would be 1, plus 4 would be 5. So this whole sub array is a happy array, right? Again, for the next variable, for 2 it is not possible, and for 4 it's only a single positive element, it is possible. So I've marked all the happy arrays in this particular case. So the value of all the prefix sums should be non-negative, right? It can be greater than or equal to 0. So from all the positions I have showed what are the prefix, what are the good subarrays. Now what we have to do is we have to find the sum of all the elements in all the good subarrays, right? So this is our question. Now we can just solve the test set 1 with brute force approach, and what we have to do is we can just create a vector v of size n+1 and a prefix sum of size n+1. Now we take the input in both of those values, and we just calculate the prefix sums for all index I. Now I initialize my answer with 0. So I just like a brute force solution for all I from 1 to n, and for all j from starting from I to less than to n up to n, right? So this will be like I'll be simulating all the subarrays. Now I just calculate the current value, whether the value of prefix sum starting from index I up to index j, I store it in current, I calculate it and store it in current. If this particular sum is less than 0, I just break out of the statement, because obviously if I have encountered a subarray, an index j, starting from I, the total prefix sum is negative, then obviously I cannot form an array further, so I just break from it. Otherwise, I just add it to my answer, because this will be storing the value sum of all the values in that particular subarray. So I just do it for all the values and I just print my answer at the end. So like this was it for today's video. I hope you guys were able to understand the solutions. So till the next video drops, keep coding, stay safe, bye bye.